Hey everyone, ready for another deep dive? Today, we're going to be talking about something really cool, anti-gravity.
Anti-gravity, huh?
Yeah, like defying gravity. So we found this really interesting article that looks at, some popular claims about this technology. And it also, gets into whether or not secret government projects could be hiding these breakthroughs from us.
Oh, wow. So like secret government stuff.
Exactly. And, the whole inspiration for this deep dive actually came from that crazy Tesla Cybertruck explosion in Vegas a while back.
Oh, yeah. I remember that. That was wild.
Totally. And get this, the guy who did it, he claimed to know all about something called gravitic propulsion systems.
Big propulsion systems, huh? Sounds intense.
Right. So that's what got us thinking, is there more to this than meets the eye? So in this deep dive, we're going to unpack what's scientifically plausible, what's probably just a misconception, and where the real frontiers of discovery might actually be.
Sounds like a plan. Let's dive in.
Let's do it. So first things first, secret government projects hiding advanced tech. Is that even a thing? Like, are we talking real science or pure conspiracy theory?
Well, it's a question that sparked a lot of debate, right? I mean, think about it. Historically, government's AVE kept some pretty groundbreaking science under wraps.
True, true. Like what?
Like the most obvious example is probably the Manhattan Project during World War II, the development of nuclear weapons. That was top secret stuff. And for good reason. You know, the science was so new, so potentially dangerous, that secrecy kind of made sense back then.
Yeah, I guess when you're dealing with something that powerful, you'd want to keep it under wraps. So, okay, governments have secrets before, but does that mean they're still doing it with, like, anti-gravity? I mean, it's 2025. Wouldn't someone have spilled the beans by now?
Okay, so here's where things get interesting.
Mm,
Back then, physics research was way more isolated. Scientists in different countries were often working in silos, not really sharing their findings all that much. But today, it's a totally different ballgame. Well, today we have this incredible global network of scientists. They're constantly sharing their findings, collaborating on projects, building on each other's work. I mean, it's amazing. If someone didn't somehow crack the code of anti-gravity, it'd be almost impossible to keep it a secret for very long.
that makes sense. It's like, in today's world, science is more of a team sport than a solo mission.
Exactly. It's more open, more transparent. Plus, think about it. Scientists, they love to get credit for their discoveries, right? It's kind of in their nature. Keeping a secret that big would be like, I don't know, like trying to hide a symphony orchestra in a studio apartment.
Yeah, that would be pretty hard to pull off. Okay, so even if it could be kept secret, is anti-gravity even scientifically possible? Like, is there any real science behind it, or is it just, science fiction?
All right, so let's get down to the nitty-gritty here. The idea of, like, completely nullifying gravity as we know it, yeah, that's still firmly in the realm of science fiction. But there are some pretty tantalizing possibilities within theoretical physics that hint at ways we might be able to manipulate gravity. Maybe not completely cancel it out, but create effects that might seem like anti-gravity.
Ooh, that sounds promising. Tell me more. What are we talking about here?
Well, for instance, Einstein's theories of relativity, right?
Yeah.
They introduced this concept of negative energy density.
Negative energy. Okay, now we're getting into some seriously complex stuff.
I know. It's pretty mind-bending. But basically, imagine a kind of anti-gravity energy that could counteract the pull of regular gravity.
Whoa. So theoretically, like mathematically, it's possible.
Mathematically, yeah. But, and this is a big grit, but creating and controlling that negative energy density on a large enough scale to actually have any noticeable effect, that's something else entirely. With our current technology and understanding, it's basically impossible. Like imagine trying to build a skyscraper using only toothpicks.
Okay, yeah, I see your point. The concept might be there, but actually pulling it off, not so easy.
Exactly. The practical challenges are just insurmountable, at least for now.
So anti-gravity, as cool as it sounds, probably not going to happen anytime soon. Bummer.
Yeah, sorry to burst your bubble.
It's okay. But, it's not just about anti-gravity, right? There are other pretty wild ideas out there about how we could, like, bend the rules of physics to achieve things that seem impossible.
Like what?
Well, like those proposed by physicist Eric Weinstein. You familiar with his work?
Oh, yeah, Eric Weinstein. He's a fascinating guy, very thought-provoking.
Totally. He talks about stuff like accessing extra dimensions for like super advanced space travel. And he even has this concept called growing the ruler to actually shrink distances. It's like anti-gravity with a twist.
Weinstein's ideas are definitely captivating. He's tapping into a very real area of theoretical physics, the exploration of extraspatial dimensions. dimensions beyond the three that we experience in our everyday lives.
Wait, extra dimensions? Like more than up, down, left, right, forward, back? Okay, now my brain is starting to hurt.
Huh. Yeah, it can be a lot to wrap your head around. But imagine this. A universe with these, like, hidden dimensions curled up so tightly that we can't perceive them directly.
Okay, so they're like tucked away somewhere. We just haven't figured out how to see them.
Something like that.
Ish.
And the math behind these extra dimensions is pretty elegant. But the thing is, there's no actual empirical evidence to suggest that these extra dimensions, even if they exist, could be manipulated in the way that Weinstein proposes.
So it's all just theory at this point.
Pretty much. It's like having a really detailed blueprint for an amazing building, right?
Mm.
But until you actually build it and see if it stands up, it's just a theory, a possibility, not a reality. Weinstein's geometric unity theory is super fascinating, but it needs that experimental verification to move from speculation to scientific acceptance.
So no extra dimensional travel for us anytime soon either. Dang it. I guess that's the difference between like really cool science fiction and actual science, huh?
You got it.
Yeah.
You got to be careful not to mix those up. It's easy to get swept up in the excitement of these really cool ideas, but we also have to stay grounded in what we can actually prove.
That's a good point. So, okay, we've debunked anti-gravity, at least for now, and we've sprinkled some healthy skepticism on the idea of extra-dimensional travel. But if those aren't the paths to, like, totally groundbreaking physics, where should we be looking? What are the real frontiers of discovery out there that have scientists all excited?
This is where things get really, really interesting. So instead of getting lost in all these hypothetical dimensions or searching for these like super elusive particles, the next big breakthroughs might come from a completely different direction. What if we looked at complex artificial systems?
Artificial systems. You're talking about like AI and stuff?
AI is definitely a part of it, but it's much bigger than that. Imagine systems with just massive numbers of interacting components, systems that exhibit emergent behavior, things that don't occur naturally but are like engineered by us. These kinds of systems have the potential to unlock totally new physics.
Okay, hold on. Emergent behavior, artificial systems. Can you be a concrete example here? Help me wrap my head around this.
Okay, picture this. Imagine a gigantic network of interconnected quantum computers, or a material that's engineered like atom by atom to have properties we've never seen before, nothing like what we find in nature. These systems would be so incredibly complex that you couldn't predict their behavior just by understanding their individual parts.
So you're saying like the whole is greater than the sum of its parts. We might see things emerge that we never even imagined.
Exactly. We're talking about new laws of physics, new principles of organization, potentially emerging from this complexity.
Okay, now that's pretty mind-blowing. So instead of just looking for new particles or forces out there in the universe, we might be able to create entirely new physics by building these like super complex systems.
Exactly. And this is where I think the real excitement lies. We're not just passively observing the universe anymore. We're becoming active participants in shaping its behavior.
Yeah.
It's a whole new way of thinking about scientific discovery. We're not just asking what's out there. We're asking what can we create? What happens when we push the boundaries of complexity? What new phenomena might emerge?
That is seriously profound. But isn't there like a risk that we could create something that we don't fully understand, something that could even be dangerous? It kind of feels like we're opening Pandora's box here, you know?
Right. I get that. It's a valid concern. And it definitely highlights why we need to proceed with caution here,
Yeah,
We need to be careful, think about the ethical implications, all of that.
absolutely.
But it also underscores just how much incredible potential this field has. By studying these complex systems, we're not just learning about physics, we're learning about complexity itself. And that has implications for everything, biology, economics, even the evolution of the universe. It's about understanding how systems interact and change over time to produce something totally new, something we couldn't have predicted.
Okay, so maybe it's more like opening a treasure chest than Pandora's box, as long as we're smart about what we do with the treasure we find. This whole concept of emergent physics is really making me rethink what's possible. It's like we're on the verge of like a whole new era of scientific exploration, and it's not just about these complex systems, right? There are other areas where we might be close to some groundbreaking insights. Like, what about that quantum measurement problem? That's like one of the biggest mysteries in quantum mechanics, isn't it?
Oh, absolutely. The quantum measurement problem. It's been a head-scratcher for physicists for almost a century now. Think about it in the quantum world. These systems exist in this fuzzy state of possibilities until we try to observe or measure them.
Right.
right?
Mm.
And it's the act of measurement that seems to force them to choose a specific state. But the question is, how does this choice happen? What actually causes the wave function to collapse?
So it's basically like, how does reality solidify from this like cloud of possibilities just because we decide to look at it?
It's a very strange thing, isn't it? And it's a question that really cuts to the core of how we understand reality itself. Some physicists believe that the answer might lie in understanding how these complex systems that we were talking about interact with the quantum realm. Perhaps the act of measurement itself is an emergent phenomenon, something that arises from the super intricate interplay of countless particles.
So we might need to look at the big picture to understand the tiniest mysteries.
It's very possible. And it shows that the search for new physics, it isn't just about finding those new particles or forces. It's about getting a deeper understanding of what reality actually is.
Huh?
How does the universe work at its most fundamental level? And could our own consciousness somehow play a role in shaping that reality?
Wow. Okay, now we're getting really philosophical.
It's true.
Yeah.
And these are some of the biggest, most challenging questions facing science today. We're not just observers in this grand cosmic drama, we're participants. And figuring out our role in all of this, well, that's a pretty amazing journey. It's funny, as we dig into all this complex science, I keep thinking back to something we talked about earlier, the whole conspiracy theory thing.
Yeah, it's wild how those ideas, even when they don't have much evidence to back them up, they still capture people's imaginations, right?
Certainly. There's something about hidden knowledge, secret societies, forbidden technologies. It really gets people's curiosity going.
It's like that part of us that wants to believe there's more to the world than what we see. Like there are these big mysteries just waiting to be uncovered.
Exactly. It's like a puzzle or a secret code. People love trying to crack that code. And with science, it's even more intriguing, right?
Totally. Let's be real, some of those theories are just fun to think about. Like, who hasn't daydreamed about flying cars or zipping off to other galaxies in an instant? That's like classic science fiction stuff.
Oh, for sure. But we have to remember there's a difference between enjoying those ideas and actually believing them without any real proof.
It's like you can love a good sci-fi book, but that doesn't mean you think everything in it is actually going to happen.
Exactly. So how do we walk that line, between that natural curiosity, that desire to explore the unknown, and at the same time being skeptical, thinking critically about the information we come across?
Yeah, how do we avoid going down those conspiracy theory rabbit holes while still staying open to new discoveries?
That's where critical thinking is super important. It's about training ourselves to look at information objectively, question things, and look for evidence before we jump to conclusions.
Basically, be curious, but not gullible.
Exactly. Be open to new ideas, but don't just blindly accept them.
Makes sense. But with all the information out there coming at us from every direction, it can be hard to sift through it all, Like, how do we even know what to believe anymore? Got any practical tips for, like, actually getting better at this whole critical thinking thing, especially when it comes to science stuff?
Oh, definitely. First and foremost, always look at the source of the information. Where is this coming from? A reputable scientific journal? A well-respected news outlet? Or is it like some random blog with no author listed?
Right, right. The source is super important.
Totally. It's easy to share an article or a meme or whatever without even thinking about where it actually came from.
That happens all the time.
And watch out for confirmation bias, too. That's that thing where we tend to look for information that confirms our existing beliefs, even if that information is wrong or misleading. We got to be willing to challenge our own assumptions, be open to different perspectives, even if they make us feel a little uncomfortable.
So it's about being honest with ourselves, recognizing that our beliefs aren't always based on facts, and being open to changing our minds when we learn new things. That's a tough one.
It's a lifelong process for sure. And whenever you come across something that sounds super crazy or just too good to be true, remember Occam's razor? You ever heard of that?
Vaguely. Refresh my memory.
It basically says that all other things being equal, the simplest explanation is usually the right one. So if something needs like a million assumptions and crazy leaps of logic to be true, it's probably best to be skeptical?
So if someone's telling me they invented a time machine in their garage, I should probably ask for some pretty solid proof before I hop in.
Probably a good idea. And one last thing, always remember that science is constantly changing. It's a process of constant revision and refinement. What we think we know today might be completely overturned by new discoveries tomorrow. And that's the cool thing about science. It's always self-correcting, always evolving.
So it's not about holding on to old ideas or rejecting new ones without thinking. It's about being open to the possibility that, our understanding of the universe is always growing and changing, and we're all in it together.
Exactly. It's like a journey we're all on together, constantly learning and updating our understanding of the world around us.
Well said. You've given us so much to think about with all this critical thinking stuff. It's more important than ever, especially with all the misinformation and crazy conspiracy theories flying around these days. But before we move on, I want to shift gears for a second and talk about something that's been on my mind throughout this whole conversation. We've been talking about all these potential advancements in science, right? Like harnessing emergent behavior, solving the quantum measurement problem, discovering new physics. But, with great power comes great responsibility, or so they say. Do we have a responsibility to think about the possible consequences of all this? Like, what could go wrong?
Oh, absolutely. That's such an important question. It's like we're pushing the boundaries of science and tech, entering uncharted territory. We got to be careful.
Yeah,
Think about the potential impact of our actions.
for sure.
We have a responsibility to make sure these advancements actually benefit everyone, not just a select few. To make the world a more just and equitable place, not less.
Can you give us some specific examples? Like, what kind of ethical stuff should we be thinking about as we explore all these new frontiers?
Okay, well, let's take artificial intelligence, for example.
Mhm.
As AI gets more and more sophisticated, we really have to wrestle with these questions of autonomy, responsibility, bias, all of that.
Hmm.
Like, what if an AI makes a decision that harms someone? Who's responsible? The programmer,
Hmm.
the person using it, the AI itself. These are tough questions, no easy answers. But we need some clear ethical guidelines as we develop and use these technologies.
Yeah, that's a tough one. And it's not just AI, right? What about the possibility that these advanced technologies could actually make existing inequalities worse? Like if only certain groups have access to them or benefit from them, it could create an even bigger gap between the haves and have-nots.
Absolutely. We have to be super mindful of how these technologies are developed and used. Who's benefiting? Who's being left behind? We want these advancements to benefit everyone, not just make the rich richer or the powerful even more powerful. That's not the kind of future we want.
So it's not just about the science itself, it's about the whole context, right? The social, the ethical side of things.
Exactly. It's about making sure these advancements serve humanity and help create a better world for everyone. It's about remembering that science doesn't exist in a vacuum. It's part of a bigger picture, a bigger story. And we have a responsibility to shape that story, to make sure it's one where everyone benefits, where we create a future that's sustainable, equitable, and just plain good for everyone.
Welcome back, everybody. It's time for the final part of our deep dive into anti-gravity, hidden physics, and the future of discovery.
It's amazing how much ground we've covered already. Debunking those anti-gravity myths, exploring the potential of those complex systems, the ethical questions. It's been quite a ride.
It really has. And, talking about all these mind-blowing concepts has really got me thinking about the big picture. The whole idea of scientific discovery. It's not just about finding the answers, is it? It's about the journey, that curiosity, wanting to understand the universe and how we fit into it.
You're absolutely right. At its heart, science is driven by that human need to know, that curiosity. We're always asking why, trying to figure out how things work, where we come from, what our place is in this vast, incredible cosmos.
I think that spark of curiosity is in everyone. Even if you don't think of yourself as a science person, it's what makes us explore, learn, push the limits of what we know.
Exactly. Think about those groundbreaking discoveries throughout history, right? Galileo pointing his telescope at the sky, challenging everything people thought they knew about the universe. Marie Curie working tirelessly in her lab, unlocking the secrets of radioactivity. Einstein completely changing our understanding of space and time with his theories of relativity. These were all people driven by an unquenchable thirst for knowledge. They wanted to push the boundaries of the known world and step into the unknown.
And those aha moments, the big breakthroughs, they don't just happen out of nowhere, do they? It's about collaboration, about scientists building on each other's work, challenging each other, refining ideas.
You got it. Science is a team effort. It thrives on exchanging those ideas, rigorous testing, debating. It's that back and forth between theory and experiment. It's that constant search for truth. A community of curious minds working together. That's what makes science so powerful.
So even when we're talking about things like anti-gravity or those extra dimensions, we're still part of that long tradition of scientific exploration.
Absolutely. Even if those ideas end up being dead ends, the process of investigating them, challenging them, pushing those boundaries, that's what moves science forward. Sometimes the biggest discoveries are the ones we make along the way, even if they take us down a different path than we expected.
I like that. It's all about the journey, the exploration, that willingness to embrace the unknown and keep searching.
And trust me, that journey is far from over. There are still so many mysteries out there waiting to be unraveled. The universe is full of surprises, and the more we learn, the more we realize how much we don't know.
Yeah. So true. And those unanswered questions, sometimes they're the most exciting ones. It's like we're standing at the edge of this vast, uncharted territory. Who knows what incredible discoveries are waiting to be made?
It makes you feel like a kid again, right?
Yeah.
That sense of wonder, the endless possibilities.
It totally does. Okay, so before we wrap up, I want to leave everyone with one final thought. We've talked about harnessing emergent behavior, potentially cracking the quantum measurement problem, discovering new physics that could rewrite the textbooks. But what if the most profound discoveries aren't out there in the cosmos waiting for us? What if they're right here, inside us? What if they're within the uncharted territories of our own consciousness?
Whoa. Now, that's a really interesting question.
Think about it. What if the next scientific revolution isn't about manipulating matter or energy, but about understanding awareness itself? What if the mysteries of consciousness hold the key to unlocking even deeper truths about the universe and our place in it? Could exploring our own minds lead us to the most extraordinary discoveries of all?
It's certainly a possibility worth exploring. After all, we're a part of this universe, right? So understanding ourselves, that could be the key to understanding the universe itself. It's a journey that takes us from the outer reaches of space to the inner depths of our own being. And the discoveries we make along the way, well, they're bound to be amazing.
Couldn't have said it better myself. And on that note, we've come to the end of our deep dive. I hope this journey has sparked your curiosity, inspired you to keep exploring the mysteries of a universe, big and small. Remember, science is all about asking questions, challenging what we think we know, and never losing that sense of wonder. So until next time, keep exploring, keep asking those questions, and keep diving deep.